is our live stream. Sorry, I'm a few minutes late. Had some internet difficulties, but we are back and ready to do whatever. Let's see. I don't think we have anyone on the stream right now, which is fine. We'll see if anyone actually does end up showing up. But if not, that's that's just what happens, I guess. Trying to think. So I have a couple things we're going to try to do today. One of them being just kind of showing a little bit of JavaScript, of kind of playing around with some things, and just kind of figuring things out as we go along. You're probably going to play. Let's see. I had a couple things in my mind today that I wanted to get around to. We'll see if we actually get to them. Definitely want to get into some functions and like a little bit of. We talked a little bit last class, which was yesterday, about that, and I figured I might as well play around with that a bit as well. What else do we have? I think that's about it. I'm just checking to see if anything else kind of came through. Yeah. Okay. No, nothing much at the moment. That's all good to go. And we're just gonna play around with a little bit of JavaScript. Console output. Okay, cool. I think this should actually work. Okay, still no one on the stream. That's okay. I will just show the stuff myself, and it's probably too early for anyone anyway. Or people didn't remember because I forgot to send out an email, or they don't care, which is also totally fine, I guess. Oh, looks like we have maybe one viewer, maybe a single person is online watching. Maybe not. I don't know. I don't know if that viewer is me or someone else, but whoever you are, if you are there, it's great to see you. Let's kind of switch over. Hey, someone is there. Great to see you. Daryl, we do have one whole person on our stream. That's always exciting. That's great. Nice to have you. So we're just going to play around a little bit with some JavaScript. I've just opened up JSBin. It's kind of an easy way to kind of prototype and play around with JavaScript stuff and HTML and a bunch of other cool things. It's kind of easy just to kind of get things up and running. We're just going to kind of take it from there. Unless, Daryl, you have anything, since you're the only person on the stream, if you have anything you'd like to see or talk about or get into today, I'm more than happy to switch things up and kind of get you involved in that. But if not, no worries. I have plenty of things that kind of go on my own. So we talked a little bit yesterday about the functional aspects of JavaScript and how a couple of things change, and I wanted to spend some time getting a little deeper in here with that. I also want to talk a little bit about the difference between vars, let, and const, and objects and other things with that as well. So let's actually do a couple things. Let's just have a couple of variables. I got my little var x. I'm going to give this a value. What should I give it? What can I just give this like a raw value? I guess 9. That's fine. Whatever. Let's do like a let. Oh, actually, I should save that for a function. Let's do a const d, and let's actually have that equal like a empty object. So if we notice, we got someone else coming in. Yay! We got 2 whole people. That's always great. The other Vinny, it's nice to see you. Better than the previous Vinny, so it's very good to there as well. If you have any questions or things you'd like to see or see me kind of mess around with, do let me know. I'm just going to kind of play around with some basic JavaScript ideas and things we talked about in class the other day. Okay, so a couple things forward to kind of talk about the difference between var, const, and let. Remember, var always hoists to the top, let doesn't, and const is similar to let, only that it can't be reassigned. Um, so they can't be changed kind of from that. Yeah, hopefully you can still hear me. I don't know if my microphone changed actually. My headsets just died because I didn't turn them on apparently. Unmute. Audio mixer. Default speakers. Default mic. That's not helping. Oh yeah, this is the thing died. I might as well just take them off then. There's no point in wearing them because they just ran out of batteries and I didn't charge them. So that's always good. Whatever. Okay. So we're just gonna continue onwards with that. I'll get to hear all that crunchy noise. I apologize. Oh no, this whole thing fell down. Oh no, oh no. Oh no, oh no. Catastrophe, catastrophe. Oh, why are you doing this to me? It's like my life is a joke to God. Let's see. What did you do? What did you do? Oh, here we go. You are too big. Yeah. Very exciting, I know. Why are you not going down? There we go. Okay. Now I'm just gonna make this go up. Jesus Christ. There we go. Haha, great. That only took all of my time. It doesn't stick on this table very well. That's the issue. It's not a big enough lip. Anyway, I do want to, Jesus Christ, I do want to get into the difference between var and const. I hope you enjoyed my ineptitude with my stupid microphone. So hopefully you enjoy that. Let's see. Oh yeah, so we can do a couple things. Let's actually play like with a let, and let's have that be like an array. Let a, I don't know, equal array. Got all these fun things there. Oh, don't want that in there. So there's a couple things I can and can't do with this. So I can do, DDs. Well, actually, let's put an object in DDs. Let's say, I don't know, hat and cool or something like that. So it has like one single object inside of there. Great. Okay. So I can change the things in const, but I can't reassign it. So I can do something like dd dot new hat equals something stupid like that. Don't do that. What else? But I can't. So I can do this, and let's do like a little, console log action here. And that doesn't work. You actually gotta like do some string concatenation inside of there. Okay, so if we were actually to run this, Yeah, I can play around with that as well. That's a good question. And some other kind of weird. I can get more into like some of the weird auto conversion stuff as well. That's a great question. Oh, it's object object. Great. That's actually not what I wanted, but it's fine. Let's try that. There we go. See? So we can do things like this, and you notice I can actually change that object. So the object itself, you notice a const, can change. This is something that people get confused with. But if I try to do dd equals, I don't know, um, a5 or something like that, and I try to do the same thing here, Phew. Here, and let's look at what's inside a. If I try to run this here, I'm going to get a type error. Oh no, constant value, you can't do that. So what constant means is that doesn't mean the object can't change and grow and do other things. Once you've created an object, you've created a connection to that. There's also something else crazy you can do. So you can also do something like, um, I don't know, let HH equal DD. Okay, so let's kill this for now because we can't do that. Here, if I'm doing another assignment, if I also do HH dot, I don't know, X equals 12, whatever, it doesn't matter. And if I were to actually see this, see if it actually changes, and we were to think what actually might happen. What? It does. So when you have assignment acts has two different things when we think about it for objects and how consts and other things work. When I say HH equals DD here, this might have been kind of confusing. Um, what actually happened and went through with that um, is that you created a pointer between them almost. So like HH is actually pointing to the same memory location of where the object DD is. So when I change HH, I'm also changing DD as well. Both of them kind of refer to the exact same object in memory. And that object in memory, as I'm referring to in a const, can also grow and change and is dynamic. I just can't reassign it to something else. I can't um, go the other way around with this. Now, if I were to do something like UHH now equals 12, I don't know, something like that. You know what I mean? And kind of going through. And now I try to, we've broken off that connection. There's no longer going to be any changes. Any changes in H now no longer refer to any changes in DD and anything else that's going inside of there. That we kind of severed that connection here. But it's kind of a way that people kind of get confused sometimes. You're looking at objects objects work a little differently in JavaScript. It's not really passed by value and it's not really passed by reference. When we talk about objects, JavaScript kind of does a little bit both. When we're talking about just the primitive types, that's a pass by value. But objects kind of pass by reference, but it's more like pass by magic. You know what I mean? It's like they are pointing to the same location in memory, but you're not passing pointers around, not really. But affecting one does affect the other. And I know that can be kind of confusing and weird. But this is like another thing I wanted to kind of show off and kind of talk a little bit about that and the difference between let, const, and var, and how hoisting stuff works. Const means you can't change it once you've assigned it, but whatever you assign can still change. Since objects can change dynamically over time, what the object of DD is, can change. I just can't reassign it to something else. I can never say something like this, to like DD equals A or something like that. This is the reassignment. I can't do that. Once I've set my const, I can't assign it to anything else. This is really advantageous for like libraries and like really complex objects and things like that that you don't want to ever get reassigned. You want those things to change and grow. You might have like a library that has an object that serves as like an interface for a framework or library that you're using. You don't want that to change or be reassigned anywhere else in your code during runtime. But you still want it to change and grow and be other things potentially. Okay, so we did get a question about JavaScript auto conversion and how to avoid it. That's a good question. So we talked a little bit about that in class yesterday. Um, things like 5, plus. Actually, let me do this so we can actually kind of see some of these changes. Or actually, the conversion stuff is easier to do. Something like this. If I actually just have like my console log opened up. This is actually like an easier way to see this. Can you still, let me see if like I can like zoom in a bit or make that bigger. That like even readable. Yeah, that doesn't look too shitty. So that's not too bad. So if I do something like, talk about this, 5 plus 2, string concatenation, because the first time we see a string, something like that happens. If instead I were to say something like, I don't know, 12 plus equals 3 plus 3 or something like that. Oh, oh, that's right. That can't have left line assignments. Yeah, that makes sense. I'm sorry. That actually makes no sense. I'm an idiot. Let's actually like let q equal, I don't know, 12. Cool. Okay. So q plus equals 3 plus 3. And you guys will, you might do, because it's the number. I meant to have q be a string. That doesn't make any sense. Let's do this again if I can actually pay attention to what I'm doing. That's the expected behavior. You were kind of expecting that. Now let's do that. Now that's what I was looking for. So the left-hand side happens first, then the other side happens through. All these other weird things kind of happen as well. Of course, we can't do anything like if I did something like 12 times, I don't know, 2 or something like that. That'll actually happen since there's no string equivalent for multiplying something. It's going to have to do something else. It doesn't do things for like other objects and things, I don't think. Let me see, like if I did something like this. Oh, it actually did. That's actually interesting. The toString operator for the array actually works. I wasn't actually expecting that. Let me see, something like to value or value of. There we go. No, it's just still does that. I'm actually surprised it did a conversion of that then. That's really interesting. Is it the string? Did it do like a string and then go back from that? I wonder. Let me see. To string. Yes, that's actually what happened. That's really interesting. So what happened is this array, the toString went through. Remember how the rules were that if the at first it does value of on an object, and arrays are just objects. So first it does value of an object. If that whatever that returns isn't a primitive, then it's going to try to do the toString value for that as well. And then kind of return to the value. And if that's primitive, which it should be a string, then everything's fine. If it's not, if that doesn't work either, then we get like a undefined, or we get like a mixed typing error. But what happened here is because arrays, the value of just literally returns the array, and arrays aren't a primitive; they're still an object. We moved to doing the toString. Part of that toString just returned the string 2, and that's exactly like doing. So this actually also became this times became this, and that's how I actually got the number 24 that actually worked. I'm actually really surprised. I wonder if I did. I wonder if I did something like equally dumb. I wonder if I did like yeah, that's not gonna work, right? Yeah, so that's gonna be not a number, because I wonder what yeah, toString. What's that of like 5 and 3? It returns back this string of whatever's inside of it. That's actually really interesting. But since that string doesn't mean anything, we can't convert that string into a number. We got nan. You know, I mean, to still try to do something. It's the same thing like if I tried to do, you know, 12 times cat or something. You know, what I mean, like it can't. You know, the two string of the number thing of cat like doesn't mean anything. Um, so we can try to do different things like that. Ways to avoiding them. I mean, there's not a lot. You just have to be really careful with what you're getting, or you can force if you want very specifically something to like a very specific type to occur. You need that for something. You can use the what do you call the like the primitive constructors, I guess, or the type constructors of the various types of JavaScript. So say something like I don't know. Let's say I have like let y equal um, 32, you know, something like that. That actually works. So we'll get y. Yeah, that works. Okay. Um, but I really want to force this to like be a number. Like I don't know what y is before I get this. So say I have like 12, I don't know, times something, some variable or something. I don't know what that's going to be yet. You know, I'm kind of like worried about it. I could force that if I don't know what's inside of y because it's you know I never made it or I don't know what type it is right now because I've been changing through runtime and other things like that. I can use something like number y, and that kind of forces that to be a number, whatever y is. And if y became, if I say like now, you know, y equals, I don't know, what's another, you know, null or something like that. You know, let's work with that. I'm going to try that again. Oh, that's 0 because the number of, you know, trying null converted to a number becomes 0. You know, and other things like that. So if I don't know, since y can change all the time, and it could have been null, it could have been a string, it could be a number. I don't know what it is, but I want to force it to be a number regardless of what's happening inside of there. Then I can force that through, you know, using number or using bool or the boolean or string. So say like string y makes the string of that the string of null is literally the string null just says null. Surprise, surprise. If I have my own object though, you might want to do different things with that. So say I don't know, say y is now an object. You know, let's say you know a3 or something like that. You know, now it's a little more complicated. If I try to do things here, yeah, like I can still get a string from it, but it's just gonna like tell me like the base type is like object object. Like it's just telling me like, yeah, you have like an object in there. I have no idea what it is. If I were to try to make a number from that, actually, let me try to let's see like number y. Yeah, it's gonna be nan because it can't understand whatever that is. It's always number always going to return nan. If it can't transform it to something like if it's cat or anything else and stuff like that. But say but you know I have something in there that's a number. I have like this value 3 or something. You know maybe I kind of want that to come out, but I need to tell it. I need to be able to have a way of like telling it to do that. So there's a couple things I can do. I can actually define for my new object either the toString and the value of properties of it. I can do that dynamically. So let's do y value of. Oh, that's not what I wanted. So this is a function. Now this just shouldn't do anything yet. I mean, it's good. Well, I mean, there's an automatic one. You get the value of in string or toString or actually methods you get all the way up to the method prototype, which all I'm sorry, the not the method doesn't make any sense. The object prototype, which all objects already borrow from. So there's a bunch of things that object kind of gives you for free, like any object already has access to. But it doesn't really help us a lot because even like with this value of, it's just like actually returning like what was inside this array or what was inside this object, and I want a primitive to come out of this. You know what I mean? Or I want something else, so I can redefine that and kind of do my own thing with it. So I can say that equals I don't know function And let's see. I don't know. Return this dot a. I think that should work. Maybe this might actually not work. Um, where did I mess up? Oh, yeah, because I'm an idiot. Yeah, this. Okay. And now if I were to do that, what? Yeah. So now it actually returns the value 3. Now you might be asking, what the hell is this? Um, this we haven't talked about it in class yet. We're going to probably talk about it on Monday. We are going to talk about it on Monday. But this is a way to refer to. It's kind of confusing because it has different meanings in different um, scoping context. So, what it typically means inside the scope of a particular um, object is refers to this instance of this object and what's going on inside of it. So, it's a way for an object to refer to itself. Now, you're like, why would you want a way to do that? Well, it's something like this in this example. Um, I don't know what my name of my object is. You know what I mean? Or I don't know other things that could be inside of it. I want to like this function needs an easy way to talk about um, the object that it comes from. There's no. If I try to do, where am I here? Go back here. If I try to do something like y dot a, that doesn't mean anything here. Y is not. There's no scope. Y isn't scoped inside this function. Actually, is it? I don't think so. It totally shouldn't work. Um, Oh, snap. No, it does. Oh, because it's in the global scope. Yeah, Y is in the global scope, and I guess the local function is still looking at it. Okay, so that actually did work better than I thought it did. But regardless of that, we could also use it's better to be using something like this. Um, because in most contexts, this thing isn't in a global scope. I could have had this in a smaller scope further down, or this function could be passed around to lots of other things. I defined this function here in this scope, but this function could have been defined in other scopes in other places or other things like that. And I could have referred to it and brought it in and do stuff like that. And I would have no idea what object this could have possibly posed to. Or I might write a function. I might have had um I don't know. Let's say function self um and let's do something like, now I have like a generic function, I'm doing kind of stuff. And now I'm like return y dot a, but like that's not really what I want. I have like the self function. I kind of want that to work on like, I don't know, any of these type of any instance of something that's like y, not particularly y itself, but anything like that, like a more generic version of that. So if I were to put something like this instead, then we have a function going through. And now I can do something like this. Self. Now, if I were to go back here, that still works. I've passed the value. Self is a function. I made value of a point, or gave it the value of self, which is also a function. And I created like a generic version of this. So self, as this function self, doesn't know anything about a y or other for that. Or maybe I want to use it for lots of other things. If I had, let's say, var dub dub equals a 32 or something like that. You know what I mean? Now this is like a completely different thing going on, right? Maybe I want with that in place, I can do something like value of equals self. I can do that here now again too. And now this will also work if I do number dub dub. See? No, that worked as well. So I was able to kind of get part of that actually working. So I created like a generic function that could, as long as an object has this dot a property to it, my self function will work for all of them, because this isn't referring to a particular object. It's referring to whichever object it's stemming from, whatever it's in the scope of. It's referring to its own object this way that. Now this also is used if it's not used in the context of the scope of an object or method inside of an object, then this refers to the global object. Um, but that's you usually don't want to be doing that. You don't want to be using this at that. In fact, if we were to like the current rules and things around JavaScript, if we use the more strict modern rules in JavaScript, and told the compiler or told the browser that's what we wanted to use, we say like literally say use script or use strict, that would stop this to be bounded to the global object ever. So it's never going to get bounded to the global object. Now, this is also interesting. The key names this is interesting that it works inside functions except for arrow functions, which we're going to talk about on Monday as well. It's kind of the only difference that arrow functions have. They don't bind this to anything. And what's really happening is that this gets bound to the object of which it's coming from. We could tell this to be bounded to other things, and it's literally something we have control over. I believe it's just like dot bind. I think is telling we can bind this to any other object or other values or other things as well. I don't remember off the top of my head though. I think it's just dot bind. I'd have to don't remember off the top of my head. And this is on the top of my head. I didn't have a whole lot planned, kind of coming into this. So those are kind of some of the ways to kind of like play around with this. I can also, let's say I want to, let's create another function. So function strings. Let's put strings with a Z. Let's be like the 90s. And let's just say, I don't know, return, ah, what's going on here? There we go. String, this dot a. Okay, that should work. And now if it's something like dub dot to string, that equals strings was a Z because we're super cool. Okay. And now if I actually were to test that, if I go to like dub to string, and now this is also the difference I think some people forget. There's a difference between the way I did the first one, to string. That's talking about like the placeholder. That's like the actual property. You know what I mean? Of talking about like what I want. The actual property itself. If I want to call the function, use the actual function, I still need to like give it some params. I need to like actually give it an argument. In our case, it's no argument. But this is what actually runs the function. See, the function actually executes. This just refers to the function. This is like the actual name. This is like the function. If I do like, okay, let's do property of. I'm actually kind of curious. Oh, native code. That's interesting. I didn't actually know that's what it would be. That's kind of cool. What else do we have here? Local string value of, because it has its own. Oh, bind. I was right. It is bind. Apply prototype. I could change the prototype of this thing. That's what the name is. It's just an F. It's a constructor. Oh, because it's on toString. Yeah, that actually kind of makes sense. The prototype. Where it's actually coming from. That actually makes a lot of sense. Let's see. Name, length, color. What's that? Oh, because it's being referred to inside of an object. Yeah, so it actually it hasn't been called inside of that. So it's just a method. We're just referring to this actual thing. Now we're actually using that function, and I can actually kind of play around with it. So that's kind of the difference between those. This just refers to a function. See, or for like the return type for that is literally just the function itself. It just tells me what my function was. It's just a string Z, and kind of playing around with that. Does that make sense? Hopefully there's like, you can feel free to type in the chat if that doesn't make sense or if you have questions on that. I'm trying to think, was there other functional stuff? Yeah, let's play around with some other function stuff maybe. Unless we want to get more into like auto conversions in JavaScript and talk a little bit more about that, which I'm also happy to fool around with and get into. But Yeah, really, the way to avoid them is more of forcing one of those to take place. So on the null, on the base, what am I trying to say? On the base types, the primitive types, we can always use string, number, boolean, object, stuff like that to force it into that certain type. But if it's an object that we created, like it's just a generic object that we made, then we're kind of responsible for setting up the toString and the value of to actually be something else. You need to talk about something else. So that's just kind of the difference, around there. Okay, so what else do we have? Let's go back to like playing around with functions and stuff. So we talked about before. There's lots of different ways of naming function. If I can spell functions, Jesus. Um, say we have a function f, and I don't know. Let's give it no. Well, no, let's give it an argument. Um, okay, just like an argument. Uh, okay, so we got our little thing here, and let's just say I want to. I don't know. Console log. Oh, it'd be helpful if I spelled console right. That'd be helpful. Um, I don't know let's just print, you know, um, R is. There's actually easier ways of doing this. I'm just being lazy. And then like we're gonna return, I'm just gonna return arg. Okay, so really simple function, doesn't really do anything. If I put, hey, so inside of that, what are we gonna get? Should be pretty obvious. Let's clear this, let's run it. Yep, arg is blah, 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 blah. Okay, so pretty standard so far. I can have another function. I can always make other functions and things like that. There's other ways of naming functions and anonymous functions and things like that. So let's let r equal, oh, not minus, this should actually equal something. This is anonymous function now. This is also going to get an argument. Let's just call this argument dub, or w, just because I can, and no one can stop me. So I want to console log. I don't know, dub dot name, right? That should be a property. That should be something. I can't remember if that's a property or if a function. I think it's just a property. We're gonna see. We're gonna see real soon. And then we're expecting like w to actually be something. So maybe we're expecting w to actually be a function. So we can call it. I'm gonna call it with my own thing inside of here. Inside our. Okay. So now let's actually like do something with r, and instead let's give it the value of f. So we're actually going to pass it a function, and we're going to call that and do something with it. So let's clear this. Let's run. What? Oh, that actually worked. That's actually cool. So the console.name worked. We have this current name is f. That's the name we gave it. I can kill. Let me kill this other stupid stuff since I don't need this anymore. I'll kill these other. Actually, I don't want to kill that because that would maybe break my other code. Get rid of that and get rid of that. Okay, so let's try this again. Okay, so arg is just saying something. You know what I mean? We have the thing, we called it here, and it did all of that stuff. And then we actually called it inside of here. So let me kill this. I don't want to use this again. So now it's printed out. R prints out the name of what this function is. W is going to be a function. It could be any function inside of there. And then we actually use W and use it inside of there. And that's where we get the second line. This is W being used, which is actually F because that's what we passed to it. And we gave it some other things. But I could do that like with literally anything. So it doesn't have to be this. I could also be like, you could do console log in there. See, console log is the function. This should work. Let's run that. See, all the same things inside of there. Oh, it's funny. The console log doesn't actually have a name. I guess I would have thought I would have at least said, console inside of there, right? Yeah, yeah. And oh, and then it's I hate it looks like it's running it twice. There we go. So it's the same thing as well. I didn't really pass it to anything. We're inside R. That's what it's actually printing inside of there. It's not doing anything else. Console log is just like literally printing what's inside of there. But we can pass it any type of function. What I mean? As long as it like accepts a string or does other things with it, and kind of handles out that type of stuff. Hopefully that makes sense a little bit more. And the opposite thing, I could do the opposite way too. I could have this like return a function, and we do that a lot in other things as well. So I don't know. It's like a stupid example. Function. I don't know. T. We're just gonna like. Oh, I need to give it some params. There we go. Okay, I got all of that. Oh, what? Why is that bothering me? No, this should all be fine. Yeah, why are you like complaining? This is nothing. What are they even complaining about? Function T. Oh god, it's using like a weird version of JavaScript. It's like really. Oh, what version of it is it using? I don't want to do that. And no, I don't want Lodash. Don't want any of this junk. Huh. Oh, it actually has semantic UI. I'm actually kind of surprised. Core 5 shim. No, don't want that. Core.js. No. Prototype. No. Yeah, that's weird. Okay, that's. I wonder why it's complaining to me about that. Yeah. Function closer expressions. Ugh, I don't want to use the Moz options. Okay, well, I'll show that later. JSBin is being weird. This would actually work better. Let's like. Well, I could do this in the dev tools. It should work here. So because the actual JavaScript that's my browser is actually running it. So let's say function t equals something. Oh, I know why. Because I'm an idiot. No, because I was trying to do a closure example. Oh, I get it. Yeah. I'm being an idiot. I'm sorry. I'm getting my wires all crossed. There we go. But this isn't going to complain. Okay. Yeah. It wasn't creating an anonymous function. Okay. No, they're right. You can do that in other versions of JavaScript of closer expressions and stuff like that, but that's not what I was trying to do. So we have a current function. I want to return something, but I can return myself another function inside of here. So let's just say function G. And what else are we going to have inside of here? Can you guys see this? Let me make this a little bigger. What is that? What? I just want that to close. Why are you being weird? Okay, that's just getting really big. I'm not liking that. Oh, that is dumb. It's trying to be reactive, but it looks terrible. Okay. And then we're gonna say, I don't know, what is this gonna be? Return G plus 2. That's it. Return function from G plus 2. Okay. So far, so good. So if I were to say var O equals T, now I could say something like O. Let's actually console log this. Oh no, let's not console log. Let's do something even more fancy. Let's use what we had before. Let's just use F. I don't want to actually do anything else with it. Say O 32, something like that. See how that works. So let's run that. And there we go. Let's actually clear it so it actually makes more sense. And there we go. I used F inside of there. The function T returns a function. So this is a function that it returns. That function is an anonymous function, so it doesn't have a name or anything like that. I could have given a name, but I chose not to. So it returns back an anonymous function. And that anonymous function, all it does is add 2, returns the argument, an argument that it's given, and just adds 2 to it. So since I've asked for O.32, that gets plussed by 2. And I also pass that value inside our previous function, f. So all f does is return that and the argument of which it came from. So if I were to do literally anything else with that, it's passing it back and stuff like that, it would, I could probably even chain that through. Yeah, that's interesting. Okay, well, that's interesting. It actually worked. Not as interesting it actually worked, but it is cool that that actually happened. I can do other things too. So we can talk even like a little bit about like closure and things from there. So let's have this be 2. Oh no, let's actually have this be x. And let's say this instead. You know what I mean? So now it's a little different. I've added an argument to t, and that argument is going to get passed to what it is. So let's say have this be 2, and it should work exactly the same way. Yeah, see, it works exactly the same way. It remembers the 2, the x inside of there, Now if I were to do something else, if I were to say like var yy equals t 10. Okay, and now I do something like, I'm gonna copy and paste because I'm lazy. Anyways, you can see it a little better. Okay. And we're gonna change this to yy. I should be adding 10 to that instead of just 2. So let's clear that. What? Yeah, that actually worked. Remember, it's almost like we've created a function that makes other functions. And what that other function does is like construct one that like adds anything to it. So let me make this like a little more clear, I guess. If it's something, if I call this like, add 10 or something like that, And so now this is a function that will always add 10. regardless of what we do with it. You know, and other things like that. Let's clear that, run it. See, we basically created like an adder. You know what I mean? That will always be that. It remembers the value from which it came from. This is called closure. And we're going to talk more about this on Monday. But it's also a key piece in functional languages. Um, whereas it remembers the oh, you can barely see my mouse. Yeah, let me see. Can I do this? Then you actually look like that. So this x, it remembers the value of what this previous argument was and how it was created. The crazy thing is, once we've made this, we can never change that again. There's no way for me to modify what this x was. So add 10 will always add 10. I can't change it to add 11 or to add 13 or any other number and stuff like that. Like it's set in stone. If I wanted it to be something different, I have to create a new function or I have to create a new value thing for it. I would have to do something like, you know, I don't know. I have to do like another expression or something. So say I want this to be like 15 or something, that would work, and then I could do this, clear, run. Yeah, see, that'll work. But I have to like do a reassignment. Like I have to recreate it from scratch. I mean, again, I have to like call it again to make that work because it's not going to work on its own. Like once it's been made, there's no way for me inside of add 10 to modify it in any way that could change that X argument that it was given when it was created, unless I had some other functions and things inside of it. There actually are ways, but you'd have to create functions inside this that would manipulate that value, which we have a few minutes. Let me actually show you an example of that. So instead of this was um, returning this, let's say it's returning, let's kill this. So let's say instead, this is going to return back an object. So I'm going to say let A equal the empty object, A dot add equals this. Yes, that is what I want. Yep. Okay. I could also do like A dot change X equals function Q, whatever, doesn't matter. What do I want inside of here? This dot X equals Q. Yes. I think that should work. Now I'm going to return A. Okay. So now this is a bit different. It's returning an object that has functions inside of it instead of the actual function itself. So none of these other things work, or shouldn't work like this anymore. So we have this O, this other side of it. So if I want this to work like before, it's going to be like dot add, because now O is an object, it's not a function anymore. And now if I do something like O dot change X to 20, and now I do this again. That should work. And I'm just going to kill this. I'm like, I don't want that there anymore. I'm done showing that example. Okay. This should, in theory, work. Let me see. Ha ha ha! Oh, wait, no, shit. It actually didn't do what I wanted it to. God damn it. No, it's exactly the same. It's the exact same thing. Oh, does the t to the 2? Why does this not work? bet I have to do something stupid like, let me see, like let um, equal x, and then this. Oh, maybe it's not this because it's not a dot this. I don't know. It might just be x actually. X equals. Let me see. Let me see if that's actually what I wanted. Yeah, that's what I wanted. I was an idiot. I was thinking too much like objects. Um, so now you see what we did a little bit different here. O is now an object. O has two methods to it, this add method and this change x method. So first, x is 2. That's the argument that was coming from here. I want to add 2 to 32. That's 34. That I'd use the change x function inside of here, and all the change x does is now takes whatever value, whatever argument I give change x, and modifies x accordingly. So now x can be changed, but it could only be changed because I created a function that allowed me to do that. There's no other way for me to access that thing otherwise. If I were to try to do something like I don't know, O dot X, like that doesn't mean anything. I'm gonna get like an undefined, you know, I know that's what is gonna happen. Okay, let me see. Yep, it's undefined. See, so it doesn't exist yet. There's no way for me to access that X because it's not like it's real, but it's not like really real. I guess it's like a private thing. Before JavaScript had more object-oriented features, like private and public uh, um, uh, attributes and things like that, like you would expect in Java and C++. That's like necessary for like data encapsulation and stuff like that. This was a way to kind of create private variables and private methods and other things like that that couldn't be changed after the fact after they were made. So it's kind of a way of like pseudo making private attributes and private variables that once set can't be changed. Unless you create literally, changer and setter functions, to it that will allow you to do that. So that's a little bit of JavaScript closure. That is all I have for you today. It is now 11 for my single viewer that stayed on. I hope you had a good time. And I will see you all on Monday. Thank you so much. Catch you guys later.